Okay, so we should see little red light flashing on the top left-hand side of our Zoom screens, which indicates the class is being recorded. Okay, let me reshare. Bing, there we go. All right, let me move this down out of the way. Okay, so as stated before, you guys are in EML4501, which is Mechanical Engineering Design 2. I am the instructor, Dr. Matthew J. Traum, and the plan today is just to walk through an introduction to the course. For completeness, I did flash the slide before we started recording. And reminded everybody of the possible consequences of turning on your camera, turning on your microphone. If you do have a question and you want to ask, but you do not want to turn on your microphone, you can go ahead and drop the question into chat. Either everybody in the class can receive it or you can send it directly to me. If you send it directly to me, I will ask permission before reading it aloud to everybody. If it's that kind of question, just to make sure that your confidentiality is preserved. The next slide is the one that we started with as you guys were sort of filtering in before class started. And the reason that I like this cartoon so much is because I think it embodies precisely what I'm trying to teach you in Mech Design 2 in 4501, which is a change of perspective, right? So up until now, you've learned to solve problems convergently. So every science class, every math class that you've taken, really all the way back through college and even back into K through 12, you're taught to solve problems as efficiently as possible, get to the answer in the easiest possible way, know that you have the right answer by comparing it to, say, another answer in the back of the book, and move on with your life and solve the next problem. So in design, it doesn't work like that. There is no one right answer. The solution process involves a pretty substantial amount of divergent thinking rather than convergent thinking. And this is very uncomfortable for a lot of students who have not done design before. And so there's going to be kind of this period of discomfort as you're learning kind of this new thought process, and your brains are kind of rewiring themselves to be divergent in their thinking. And so the way that I like to kind of explain or embody this in a way that I think makes sense to everybody is we're changing our perspective in design from the perspective of I'm doing everything as the engineer to make my life easy, to I'm changing my perspective to that of the customer, where my goal is to make the customer's life or the end user's life as easy as possible. And we see that all the time in engineering solutions, right? So if you're solving a fluids problem, right, the first question is, am I in an Eulerian or Lagrangian reference frame? And you select the reference frame to make the problem easy to solve. Thermo is the same way. You select a particular control volume or control mass, depending on whether you're an open system or closed system, and selecting different system boundaries make problems arbitrarily easy or arbitrarily difficult to solve. And so you always try to choose the easiest way to solve a problem. Well, in design, sometimes you have to pick the harder path forward, because even though it's more difficult for you as the designer, it's ultimately easier and better for the customer or the end user. And so I think this cartoon embodies that perfectly, in that if you're a bad design engineer, you've got the perspective of the parents, right, who think that they've made their kid's day by putting this wonderful animal mobile up above of the baby's crib. I love it. Me too, say the parents. But then if you look from the customer's perspective, which is the baby laying in the crib, he's looking up and he gets to see a bunch of twirling animal butts. Right. So that's the kind of change of perspective that I want us to start thinking about and internalizing and mastering as we walk through this class together this semester. So anyway, I like to start with this because I think it just embodies precisely what it is that we're trying to do in design. The other thing that I wanted to show before jumping into, I do actually have an outline for the lecture today, but this is paramount in its importance, and so it came before the outline. This is at least my mapping of the formal engineering design process, and this comes from a synergy and amalgam of multiple different literature sources and my own experience as a design engineer in industry. Um, a little bit of orientation here, and you guys have seen this before, right, or some version of this, because you've all taken DML, during which you walked through an engineering design process to develop a final functioning product. So this should be review, but for sake of orientation, 4501, which is Mech 2, and 4502, which is Mech 3, are connected to each other in that our job in 4501 is to generate the paper design for a product that meets a set of customer needs. And now we have an external customer that I'll talk a little bit about later on, but we've got a set of customer needs from our customer, and we have to develop a paper design that addresses those needs, um, to meet the expectations of the customer. And then we're going to hand our paper designs across the boundary from 4501 into 4502. And the students in 4502 are responsible for taking our design ideas and converting them into functional prototypes that ultimately can be scaled up to mass production. And so that boundary between 4501 and 4502 in this overall 20-step engineering design process is this green dotted line here, kind of maybe 2/3 of the way down. So 4501 is on the top and 4502 is on the bottom. So for 4501, we're going to start with step number one, identifying the problem, and we're going to march all the way through this process, step one, step two, step three, and so forth, to step 11. Step 11 is the final design review. And you guys are going to give final design presentations in the last week of the course, where you're going to showcase your solutions to this set of customer needs that were given by our customer. And you're going to present those designs both in a poster format and an oral presentation format to a panel of uh, design faculty. The customer is represented both by mechanical engineers and by biologists, and our industry sponsors, Northrop Grumman and Cummins, will also send engineers, and those panelists will evaluate your final design and ultimately decide which of those designs crosses over the system boundary from Mech 2 into Mech 3 and moves forward into the prototype phase. So we'll march through this entire process with the end goal of being that presentation to our panelists in the last week of class. Now, I've represented this as a linear process, but you guys know, because you've been through DML, that engineering design is not a linear process, right? But we have to represent it that way so that it makes sense. But as you guys walk through this process, you'll find that there are situations where you learn something in a later step that ends up informing something that you should have done in a previous step, and you might have to take steps backwards. And there are a few cases where those steps backwards are actually formalized, these oval decision points. Does the solution exist? Does the customer like the idea? Does the customer like the idea? And those send you back, sort of like a game of chutes and ladders, back down the slide to an earlier stage of the process. But you guys will also discover, as you're walking through the process yourselves, that it's not linear, that there's a lot of situations where you have to take one step forward to take one step back to take two steps forward. And so you guys will experience that live as we walk through this process of designing a product for the customer. The other thing I'll say while we're on this slide is that every class session, when we begin, I'm going to bring this up and I'll actually highlight where we are in the design process and how what I'm talking about in that day of lecture corresponds to where we are on this map. So you guys are going to see this a lot. And as we walk through, you'll see how all of the individual skills and techniques that I'm teaching in this class map onto the overall design process, so you can see hopefully how it all fits together. Okay. So that being said, let's jump into the lecture outline. There are four things that I want to talk about. And the first is to explain the text-based feedback system. Um, so when this class is taught in person, and I should say, this semester the class is going to be taught all online, completely online. So all you need is to be in a place with a mailing address and an internet connection, and we are going to mail you a laboratory kit, and we're going to deliver all the content online through Canvas and YouTube. So you do not need to be physically at UF, and you do not need to be in Gainesville to take the class and be successful. Um, However, when it is taught in person, which it was in 2019 and 2020, at least the beginning of 2020, when I taught the class, I would get a lot of feedback, right? Just in the classroom, watching the students in the class as they went about their job of being students, right? So I would start a lecture and somebody would start checking their cell phone. Another pair of students would start having a conversation. A couple students would grab their backpacks 15 minutes in and walk out of class. And that's how I knew I was doing a really bad job and I needed to somehow improve my delivery or improve the value of the content, to really capture your interest and your attention. And so I do not have those visual cues in an online environment, right? Like I'm looking right now at the gallery of participants. There's about 25 students in here now. And I see Alessandro and I see Tomas, but I just see um, static pictures of them. And then everybody else is just a name, right? A white name on a screen, which is fine. You don't need to turn your cameras on, but I don't have any visual cues at all, right? Are you guys yawning? Are you cheering? I have no idea what you're doing behind your computers. So I need a way to get some real time or at least near real time feedback to know what I'm doing well and to continue to do those things and figure out what I'm doing wrong and improve so that we don't have an entire semester of me making the same mistake over and over and over again. So I've devised this system. It's a cell phone based system. It is completely anonymous. And if you choose to participate, you'll really help me out because you'll give me much needed feedback to improve my online lectures that I wouldn't otherwise get. And you'll help me by every time we have a synchronous interaction by answering for me 3 questions. The first is going to be what went well. The second is what can be improved. And then the third one is going to be a custom question that's tailored to the particular situation that we're in, right? So we might be halfway through class and there might be some techniques, say trade studies, and maybe I'm interested in how well you're utilizing trade studies in your down selection process. And so I might ask a question like, you know, how are you using trade studies to inform your down selection process? And then you can answer that question so I can get feedback on how well the content is being absorbed and used. Um, yeah, and I've used this before, and it works really well to get that kind of feedback. So here's how it works. Um, it's all cell phone text based. So there is a server sitting in the merge lab, which is EML, not EML, sorry, it's MAEC 010, the design instruction lab. And there's a server sitting there that's controlled by Noel Thomas, who is our teaching technician. Noel is a UF mechanical engineering grad, who now is the technician that sort of keeps the back end of the class running. So he runs this computer. That computer is attached to this phone number. So if you go to the text feature on your cell phone and type in 352-306-5267, and text the word add to that phone number. You only have to do it once. You should then receive a text notification that you've been added to the system. I don't see any of this. I mentioned before, it's completely anonymous. So Noel does see the phone numbers, but he doesn't share them with me, and there's no way for me to get at them. So the whole system is anonymous. And if you just add yourself one time, sometimes it takes a couple minutes to get the confirmation. But if you just add yourself one time now, your phone number will be in there for the entire semester. And every time I send out this survey at the beginning of class, you guys will get pinged on your cell phones with the survey questions. Your phone numbers stay in Knoll's database for the course of the semester, and then on week 15, when the class is done, Knoll goes in and wipes them all from the database, so we don't keep any of those phone numbers in the long term. When class starts, I will send out a survey. I usually send it a few minutes before class to kind of give you a reminder, like, oh, hey, it's time for class to start. So you'll get the survey a couple minutes before class, and it's those 3 questions: what went well, what can improve, and then again the daily custom question. And so sort of two caveats here, two things that we need to improve about this system. So one is that because it is text based, it comes through on your cell phones, you have to answer the question sequentially before you can answer the next one. So if I'm having a really bad day and there's all kinds of things that you want me to improve, you do have to answer the question, what went well, question 1, before you can answer what can improve. And in some cases, when I'm having a really bad day, students will just like send me a blank, like what went well, blank, and then what can improve, and then several ideas. So that's fine, but you do have to answer the questions in sequence. The other caveat is because we have 3 sections, we don't have a way to discern which phone numbers correspond to which sections because of the anonymity of the system. And so you're going to end up getting pinged 3 times every day that we have a synchronous class meeting. So just ignore the 2 text messages that are associated with the sections that you are not in, and respond to the one that you are in. And hopefully that's not too annoying. I apologize for that, but the complexity of making it section by section was so much that it became difficult for the system to work. And I guess just as a disclaimer, I don't think anybody pays for text messages anymore, but in case you happen to be on a cell phone plan where you do still have to pay for text messages, this is a text-based cell phone system. And so if you do pay per text message, every time you send a message, you'll get charged by your provider for that. But hopefully we've evolved far enough into our cell phone plans now that nobody pays for individual text. But I do have to say it just as a disclaimer. Okay. Before I move on to a brief introduction about myself, are there any questions I can answer about the text-based feedback system? No? Okay. Great. Okay, great. So I either explained it really well. Oh, okay, good. So thanks. Somebody said no. I never know, right? I don't ever see any reactions. So it's like, you guys could all be asleep. Okay, perfect. So let's and we'll start this on Wednesday, by the way. So if you guys sign up today, and Wednesday is when we'll actually start delivering real course content. Today is just kind of an introduction. You'll get your first messages on Wednesday when we meet again for class then. Let's see. Solomon's asking, would you prefer it if we turn our cameras on? It doesn't matter to me. I like to see you guys, but I know a lot of people have privacy concerns, and especially in this section, given that we're recording, there's no need to turn your camera on. But it's nice to see you guys time and again. There's been some unusual situations where I've actually encountered students in person who were in my class, and I didn't realize they were who they were because I don't know what they look like. So, I do have a photo roster of you guys that I could go through to see what you look like, but it's kind of weird and awkward to be like, oh, I've never actually met you in person, but, or even worse, like I met you in person, but I don't know what you look like. But no, it doesn't matter to me either way. But if you'd like to turn your cameras on, it is nice to see you. Any other questions while we're here? Hey, there we go. There's one. All right. All right, so let's move on to just a brief personal introduction. So I have a much longer version of this that I've created as a YouTube video and posted up on YouTube, and I'll link it into the Canvas site so that you guys can access it. So I'm just going to give you a short snippet. of my overall history that describes kind of how I got here, right? So my academic history, the companies that I worked for, kind of a weird period in my life when I had a very, very serious illness and kind of had to step away from my professional life for several years. But I'm going to give you guys a snippet that's relevant to Capstone, because it, in a way, I think embodies what I want you guys to get out of this class and why I teach the class the way that I do. So 1,000 years ago, I was an undergrad student at University of California at Irvine, which is in Orange County in Southern California. I grew up in Northern California in the San Francisco Bay Area, a little town called Orinda in the East Bay, but went to school in Orange County in Southern California. And I was an undergraduate research student at the National Fuel Cell Research Center, NFCRC, within the Advanced Power and Energy Program, APEP, at UC Irvine. And as you guys get to know me, you'll discover that I built myself as an energy guy. I'm an energy thermal fluid science guy. That's my interest and my area of research. And so I end up spending a lot of time talking about energy because that's what I love. But I developed my love for energy science and energy technology because of my undergraduate research at NFCRC and APEP at UCI. And because I was an undergraduate researcher before undergrad research was really like a thing. I was the first one, and they sort of had me do a little bit of everything. I was kind of the gopher that went around and helped everybody. And so I got to work on molten carbonate fuel cells, environmental air quality monitoring, aero-derived microturbines, and of course, building integrated solar photovoltaic power. And even though my graduating class did not require a capstone design project, it turns out ABET 2000, ABET is the accrediting body for engineering and technology. ABET changed the accrediting rules so that looking forward, programs needed to have a capstone design course that sort of capped off their engineering curricula. And so even though I did not need capstone, I realized that I would be graduating with a bunch of students a year or two younger than me, who would have a capstone experience because of the change in the curriculum. And so I wanted to keep myself competitive and ended up volunteering to take on a capstone project, even though I didn't need to, just to make myself more marketable to potential employers. And this turned out to be a very good choice. So my project was sponsored by a company called Next Tech Power Systems. And Next Tech has an energy blending technology where they take DC, direct current, which is produced by solar photovoltaic arrays, and direct couple that DC right into loads that accept DC, like lights, for example, and electronics and computers and all those things run on DC. But what normally happens in the grid is that uh, electrons are generated by this photovoltaic array, and to be fed onto the grid, they have to be converted from direct current into alternating current, DC to AC. That process is called inversion. And then fed onto the grid, and then the electrons have to be converted back into direct current so they can be fed into our electronics. And that process is called rectification. And so if you have a solar array, in order for a solar array to run a bank of lights, you first have to invert and then rectify the current. And every time you change the form of the current from AC to DC from DC to AC to DC, there's an efficiency loss in that process. And so Next Tech's value proposition was to eliminate the inversion and rectification steps and take the solar generated electrons as direct current and pipe them directly to the lights. And in so doing, you save about 10 or 15% in terms of efficiency savings. And that translates into a money savings. And ultimately, the system pays for itself. And the payback periods were really short. It was like 2 or 3 years for a Next Tech power system, which is phenomenal for like renewable energy systems. Like photovoltaic arrays today have paybacks of like 10, 15 years. So a 2 or 3 year payback was exceptional. And so that was my capstone project. was to try to figure out how to install this Next Tech device in the visitor gallery of the NFCRC and run it off of this photovoltaic array. So my job was to design all the wiring and the power distribution and the display that showed how much energy was being produced by the solar cells, and to make sure that the lights turned on and turned off when they were supposed to, and to wire the whole thing. So that was what I did for my capstone design. Now, just like you guys will do at the end of the semester, I gave a final presentation, and my major advisor, professor who was advising the project, was there. A couple other faculty showed up, and then the Next Tech chief engineer. And I should mention, Next Tech at the time was based on Long Island, in a town called Ronkonkoma in the state of New York, so all the way across the country on the East Coast. And the chief engineer for the company actually flew out of New York and came to be at my presentation in person, because Nextech was interested in, this project that I had done. And I should also mention that at the time, Nextech had not actually sold or installed a single commercial unit, right? It's a small startup company, about 15 employees, and they were still trying to market and sell their product and sort of get demonstration units out there. And so ours was kind of a beta test demonstration unit. And so, I gave my presentation and things went really well. And when it was over, everybody got up and left. And there we were, me and the chief engineer from Next Tech Power Systems, sitting in a room with lights that I had wired so that they were running off of a Next Tech powered solar system. And I looked at the chief engineer and I said, his name was Wayne. I said, Wayne, you do realize that I'm the only person in the world that's installed a Next Tech box outside of the Next Tech corporate headquarters in Ronkonkoma. You really should give me a job because I have that very unique expertise. And he looked back at me and he's like, actually, that's exactly why I'm here. And he then proceeded to tell me that the reason that the company flew him from New York to California to watch my presentation was to effectively vet me, and if I did well, to offer me a job at the company. And so I got offered a job on the spot, and literally woke up the next morning and started to work for Next Tech, having just graduated with my bachelor's degree in mechanical and aerospace engineering. So it's an incredible capstone success story, and I'm hoping, to replicate that and to help you guys replicate that in your own careers. So here's the interesting thing: is Next Tech, as I mentioned, is located on Long Island, which is over here in New York. But at the time, the state of California was deregulating its power market, and it was a disaster, right? So there was rolling blackouts, rolling brownouts. It cost the power companies more money to generate the electricity than they could charge customers for it, because they deregulated the generation before they deregulated the customer sales side. Power companies were going out of business left and right. I mean, it was a mess. But it was a great environment for a new startup renewable energy technology company. Because there were tons of people who were looking for alternate ways to power their businesses and power their homes. And so Next Tech was really, really nicely situated to be a player in that market. And so they opened a satellite office in Sacramento, which is the state capital of California. And I was located in California in that office. And it was just me and one other guy. The vice president for business and sales was in the Sacramento office, and me. And the rest of the company was still on the East Coast. And so the country was so big and there were so many potential projects, that the way that we ended up kind of breaking things down was any engineering decision that affected any of the customers east of the Mississippi River, those were handled by engineers at the corporate office in New York. But any engineering decisions that affected any customer west of the Mississippi, that was up to me. And so I, literally, like, 24 hours before, I'd been an undergrad student at UCI getting my degree, and I woke up the next morning and I'm all of a sudden like basically the senior engineer on the West Coast for this energy technology company. And so I got to interact with engineers from GE, from Siemens, SoCal Edison, like all kinds of huge power companies, engineers that had been practicing in the field for 10, 20, 30 years. And here I am, this little 20-year-old guy, like, basically going blow for blow with these, amazing, incredibly qualified, incredibly experienced engineers from all these other companies. So that just give you a sense of the power of the degree that you guys are all about to earn. You're all within 1 or 2 semesters, I think, of getting your bachelor's degrees. You will get that degree, and literally the next day you'll be vested with incredible amounts of responsibility as a result of going through the education process that we provided for you here in UF in particular, and higher ed in general. So what did I do with my newfound power as the senior engineer on the West Coast for Nextech? Well, it turned out that the NFCRC was still having some problems with the installation that I did, and it was because, again, California was suffering from rolling blackouts and rolling brownouts, and so the Nextech box allows energy blending. So you can bring DC in from solar photovoltaic cells. You can bring AC in from the grid. You can blend it together to produce DC that goes to the lights. But then if it's dark outside and the grid goes down, the lights go off. And so Nextech added a capability where there is a battery backup that you could add. So you would charge the battery during the day, and then at night, if there wasn't a source of power, you could discharge the battery and use that to continue running your DC loads. And so I ended up finishing the project that I started as my capstone by adding a battery backup system to the Nextech installation at UCI. And then with that system in place, we had this really cool kind of showcase beta test of the technology that we could then market to, potential paying customers. And the first paying customer that showed real interest was Whole Foods Market. Now, you guys all know Whole Foods because they just opened a big store in Gainesville. And they're now owned by Amazon, right? So this is now a big national conglomerate company. But at the time, they only had 3 stores, and they were just getting started, and their stores happened to be in Northern California. And Whole Foods at the time was still sort of similar to the way it is today, trying to kind of market themselves as like, healthy food and natural food and kind of, environmentally responsible brand. And so they were really interested in putting solar on their roof. And so they had courted about a dozen different companies to give them various solutions to solarize their roof. And Nextech was one of the companies that they invited to give them a sales pitch. And so this was their flagship store in Berkeley, California. And so myself and the vice president of sales in the Sacramento office drove down to Berkeley and gave these guys a sales pitch, gave them a building energy audit, gave them a sense of how much the system would cost, how much money they would save. And in the end, as a result of my work in collaboration with our business VP, we managed to sell them a system. So it was the very first direct coupled commercial solar photovoltaic system in the world. Was basically my sale at Whole Foods Market in Berkeley, California. And it's still there, and it's still working even 20 years later. But so that was like a huge, huge, huge success story for me that all started because I decided to do capstone when I didn't have to, and ended up sort of leveraging capstone into this amazing opportunity. So, and this experience with Nextech, as you guys will see when you watch my longer video, if you choose to watch it, I ended up, after working for Nextech for a period of time, going to grad school, getting a master's degree, a PhD from MIT. But this experience at Nextech really kind of enamored me to working with small startup companies. So I worked for a big company one time, didn't really like it so much. And so built an entire career out of basically starting and supporting small energy technology companies and education technology companies, all because of this initial experience at Nextech. So anyway, kind of a cool story. And what I'm hoping is that you guys are able to leverage your capstone experience in the same way to kind of catapult you into your first jobs out of college, and to use the experience that you get in this class working on this product to accept the responsibility of being practicing engineers and do an exceptional job for the companies that you work for. So, okay, so let me stop there. That's enough Matt Traum war stories. Can I answer any questions about that professional experience before we move on? Okay, I think we're good. So let's just move on to some course housekeeping. Aha, okay, what made me decide to get my PhD? That's a long story, but ever since the short answer is ever since I was even all the way back in high school, but definitely in college, was really interested in teaching, right? So you guys might notice that my title is senior lecturer, not assistant professor, associate professor. And so what that means is that I'm hired by the university to focus on teaching and instruction. And this has always been my passion, to work with students and to teach engineering. And so for me, getting the PhD, yeah, I did some interesting research, and it was a good experience. But ultimately, for me, it was a pathway to be able to teach engineering at the college level. So that was why I made the decision ultimately. But yeah, thanks for the question. That's actually a good point to make. Is that I am a teaching focused guy, and so hopefully I do an okay job teaching this class. Okay, so let's do some housekeeping stuff. So the first thing is that we do have a YouTube site that operates in parallel with the Canvas site. You will be able to access all of the videos by clicking on links that I'll embed in Canvas that take you to YouTube. But the YouTube site is operated by the Merge Lab. The Merge Lab is a lab run by Dr. Sean Nemi. He's the principal investigator. I'm a co-investigator affiliated with the lab. But our interest in putting together a YouTube site is once you guys graduate from UF, you'll no longer have access to any of the course Canvas material when you graduate. And so the idea is to put all of the videos and course content up on a YouTube page, which is externally accessible to you, so that even after you graduate, you can continue to access this course content. And so, if you're so inclined and are interested in getting kind of notifications when we update things, I suggest that you subscribe to the site, and the URL to get access to the site, the YouTube site, is there. So that's number one. Number two is that the class is taught completely online, and so all course content and assignments are posted on Canvas. In general, I post new assignments on Fridays. It's usually Friday after class, so like Friday afternoon, Friday evening. And then assignments will be due following Friday at 10 p.m. And in some cases, there's bigger assignments that are due 2, 3, 4, 5 weeks out, but it's always assigned on Friday and then collected on Friday at 10 p.m. And Friday at 10 p.m. is kind of a weird time. We did this in fall 2019, and it actually worked really well. And I've been sort of trying different deadlines, and this is the one that seemed to resonate with students the best. The reason that it's Friday at 10 p.m. Is because we'd like you to have a weekend, right? At least with respect to this class. And so previously I had deadlines on Tuesdays. And so students would spend like all weekend working on 4501 stuff and basically burn through their entire weekend. So by putting deadlines for assignments on Friday evening, it forces you to finish. And then at least with respect to 4501, you have a couple of weekend days where you don't have anything else that's pressing in terms of a schedule, to kind of relax and decompress a little bit before you jump back in on Monday. So that's the thought process behind Friday at 10 p.m. For those deadlines. And you'll see all those deadlines pop up on Canvas as I post the assignments. Speaking of which, number 3 is to please turn on your Canvas notifications. So when I do post an assignment or new lecture notes or something like that on Canvas, you are aware of it through email. So please remember to do that. We are going to meet three times a week, right? So there's a total of 9 course meetings because there's 3 sections. We're going to meet for the first 3 weeks, Monday, Wednesday, Friday. And then after the 3rd week, as you guys will see in a second, we're going to switch to a different schedule where we're going to meet and have synchronous interactions on Mondays, give you guys a break on Wednesdays for the most part. And then on Fridays, there's going to be open virtual lab hours. I'll describe that in the next slide. But these Monday meetings are going to continue all the way through the semester until April. We meet 8:30, 10:40, and this class is 12:50. I do strive to make each synchronous lecture essentially the same. There are going to be little differences. Students ask different questions, but the slides and the content is going to be the same from one to another. The last lecture of the day is the one that's recorded. So this one that starts at 12:50 is the one that we record. And I will record the lecture, I will post the lectures on Canvas after they're processed through Zoom. So if you happen to miss a lecture for whatever reason, or you want to go back and kind of relive something that we talked about, you'll be able to get access to those videos through Canvas, which will then take you to a link that's within this YouTube site that I posted on the top of the slide. Okay, number 5, open virtual lab hours. So when the class meets in person, like what we did in fall 2019, we would have 1 day a week of open lab hours where students would come into the design lab and be able to work together and collaborate, ask questions of the instructor, the teaching team, and so forth. And so we try to replicate that virtually with open virtual lab hours. Those will start the last Friday of the month, January 29th, and they will run on Fridays from 10:30 a.m. to 1:40 p.m. So they're right in the middle of class time. And so instead of having like a class where we actually discuss content, myself and teaching team members will be there in a Zoom meeting basically that entire time to answer and address questions that you have and help you with your design projects. And we'll start that on the 29th. Speaking of design projects, there is going to be a major project in this course, which will be introduced by our customer in the 5th week. It is a biomedical laboratory device. It is something that I think should be a commercial product, that there's definitely commercial demand for, but that does not yet exist as a commercial product. We have actually submitted a preliminary proposal into the UF College of Business business plan competition, just a placeholder, so that if there are any groups that are interested in writing a business plan and being in the business plan competition to get funded, that option is open to you. So if you want to talk to me over email or on office hours after class, I'm happy to talk about how to get you plugged into that. But groups will be somewhere between 8 to 10 members, 8 to 10 students per group. We'll introduce the project to you guys in week 5. And I do ask that all group members be in the same section. And the reason for that is because later on in the semester, we do have some synchronous activities, design reviews, interactions with our corporate sponsors that require everyone to be at the same place at the same time, virtually, all together. So we do need you to be in the same section. And so if you do want to kind of move around so that you're in sections with people that you like and work well with, so there's a potential that you end up in the same group, I ask you to please make those moves before the add drop deadline on the 15th. We cannot move you into a different section after the 15th. So please make those moves and finalize them before the 15th, so that you're in a section with people that you work well with. The final thing that I want to say on this slide is that there is a syllabus and a course schedule. I just realized that the link to the syllabus is broken in Canvas, so I've got to fix it, which I'll do right here in a moment after I close the lecture. So you will be able to access the syllabus and the course schedule through Canvas. I didn't want to spend a lot of class time talking through the syllabus, because you guys get that in every other class and most of the syllabuses are the same anyway. So I'm going to record myself just sort of walking through the syllabus, talking through the syllabus in an asynchronous lecture, and I'll post that up on YouTube and on Canvas, so that if you guys want to hear kind of my talk through of the syllabus, you can. But I think it's a better use of class time to go over the things that we talked about today, rather than spend time just kind of walking through a syllabus that you guys can read. So if you do have questions about the syllabus or the course schedule, feel free to shoot me an email. My email address is here. And the last item in this topic is one date that I ask that you hold in reserve, which is that you guys are going to present your major design projects as posters on Monday, April 19th, 2021 from 6 to 8:30 p.m. It's Monday of week 15. That is a day and time where I'd like you to be available outside of regular class time. And so I ask that you just put this on your calendars, so that you don't schedule something on top of it, later on and forget that this is a course obligation. It is scheduled as a night exam. So if you're familiar with it, with the evening exams, they attendance is required for those. So this is the one time outside of regular class that I ask you to be available. You guys will give poster presentations in a showcase symposium format. So it's going to be the entire department, alumni, sponsors, folks from Department of Defense, industry sponsors, design faculty, other students, like the entire UF mechanical and aero community is invited to come to this event. And it's a pretty big deal. That's why we do it at 6 p.m. is because we have a lot of West Coast alums who want to attend. We used to do it in the mornings and they couldn't come. And so now we do it in the evening so that they can attend. Okay. We've got about 2 minutes left. So can I answer any housekeeping questions?
That the presentation you were talking about, is that going to be us in person presenting something, or is that going to be virtual?
It's going to be
in person.
No, it's going to be virtual.
It is virtual. Okay.
Yeah. Cool. Yeah. You don't have to be in Gainesville. You can be anywhere with an internet connection and satisfy all the requirements.
Okay. All right. That makes sense. Thank you.
Yep.
So when you mentioned the groups for the final project, so that's still like randomly assigned, correct? Even if we have friends in the same section?
Yes and no. So we are doing a pedagogical study this semester to try to figure out the best way to assign groups. And I don't know which group is going to fall into which section because I'm not running the study, but so one section is going to be randomly selected, which is what we've done in the past. Another section is going to be friend-based, and then a third section, we're going to do a skills survey, the way that Mike Griffiths used to do it, Dr. Griffiths, and assign you guys based on kind of making complete groups with a total mechanical engineering skill set. So each section will be assigned in a slightly different way. And I don't know which section is going to be which because I'm not running the study. So I can't tell you in advance, like which section to put yourself in to get, the kind of outcome that you want. But your chances of ending up in a group of people that are your friends or that you like to work at is higher if you're all in the same section. It's not guaranteed, but it's higher.
Okay, thank you.
Yep. Okay. Any other questions? Okay. Well, gosh, I'm right at the end of time. Let me just spend a minute talking about my course goals, and then we'll wrap up. 4 course goals. 1 is to teach you to embrace and solve open-ended engineering problems. And my experience here comes from my own design course. Capstone and design were kind of 2 different things at UCI. And when I took design, our project was to design and build a device that was able to generate ice and then put ice into a cup. And so my team designed and built something like this. It wasn't quite as polished, but it was a device where you pour water in. There was a refrigeration system. The water would turn into ice, and then the ice would be dropped into a cup to satisfy the requirements. And we thought that we had this thing nailed because our solution looked almost like this. It was beautiful. It was like a tabletop appliance. The team that actually won showed up to class with a rubber bottle filled with water that they had frozen in a freezer the night before. One guy pulled out a hammer and smashed all the ice in the bottle for about a minute. They opened the rubber bladder of the bottle and they dumped the ice into a cup, and that was their solution. They probably spent 20 minutes thinking about that solution, whereas we spent weeks building this thing. And they ended up winning with that as opposed to that. And really just the take home message is that there are multiple different ways to solve problems. And so that's one of my key goals for you in the class, is to start to get you thinking about divergent thinking and open-ended problem solving. Number two, as I mentioned before, is I want to prepare you for professional practice or grad school. And the way that I do that in one way is to make you more attractive to employers by showcasing your work products. And so we are going to help you develop a portfolio that we're going to publish online that will be available to you as you go out into the job market, that you can point to and say, this is work that I did and it's amazing, and hire me because look at all this cool stuff that I've done. So we're gonna produce that in the context of the course. And then finally is to just equip you guys with war stories, right? To give you guys design experiences that you can talk about when you go out on these job interviews. I've graduated literally hundreds of mechanical and aerospace engineering students. And when they come back and talk to me about why they were successful in their job interviews, it always comes back to being able to talk about those capstone experiences. And so I want to make sure that you guys are able to, even though we are, remote online, have those same kind of war story experiences to share with potential employers. So those are my goals. The rest of this stuff is just backup slides. So these are the ABET outcomes that the course addresses. These are the Bloom taxonomy levels that the course addresses. And the very last thing that I want to say is just that there is an assignment due this Friday, which is simply to send me, well, not send me, but post on Canvas your resume and a resume worded score. Resume worded is an AI and artificial intelligence that reads your resume and gives you a score based on the quality of your resume, the professionalism of your resume. And in the resume worded assignment embedded on Canvas is an explanation of how to use resume worded to get that score. So hopefully no additional explanation is needed. Okay, with that, let me wrap up there. I'm 3 minutes over, so let me stop right there. Stop recording, and I'll stick around